Given the crane that was in this yard that simply could not tumble, it had served well and faultlessly for 30 years, did tumble. It looked like a calamity for the shipyard and for its clients. But necessity is the mother of invention, and the yard, assisted by Mammoth, found ways to overcome the difficulties, and the delay in the building program was confined to about 2 months.
Modern shipbuilding in the face of today's international competition is a great challenge for any shipyard that operates in world markets. Not just because of the rapid technological developments in this field and the steadily increasing size and complexity of the new buildings, but also, and most importantly, because of the extremely hard competition in the worldwide shipping business. So in the long run, a shipyard that wants to remain successful has to be highly productive and highly innovative. Odense Steel Shipyard, the Lindau Yard, and the other yards in the Odense Steel Shipyard Group have taken up this challenge. The Lindau shipyard has been among the world's leading and successful shipyards for decades and is determined to keep that position. The Odense Steel Shipyard Group provides maritime transport and service solutions that are recognized throughout the world as being of the highest quality. The Odense Steel Shipyard was founded in 1917 by shipowner A.P. Møller, and since then it has been part of the A.P. Møller Group, one of Denmark's leading worldwide operating enterprises with more than 50,000 employees, offices in over 100 countries, and a fleet of more than 200 vessels with a total dead weight of around 10 million tons. All types of modern vessels can be built here. The latest new buildings include the world's largest container vessels and the world's first double-hulled crude carrier. The shipbuilding process starts with the design of the 140,000 steel parts and the total of approximately 500,000 components that go to make up a modern container ship. This takes place in our R&D department using modern CAD technology. Here we transform creative ideas and innovative technology into highly advanced ships that provide increased efficiency and greater profitability for the customer. These 140,000 small steel parts are assembled piece by piece into bigger and bigger elements until they become the final blocks from which the ship is finally assembled at the building dock, using our majestic gantry crane. This graphic shows how many of these blocks are needed to build a ship. As we fly over our building dock, one can see the new building in the center consisting of already assembled blocks, and the next blocks are ready and waiting at the dockside. Now let us have a closer look at how we build our ships. The raw steel plates that arrive by ship at our yard are transported to the cutting areas. Here, the numerous shapes and sizes of the steel elements are cut using computer-controlled cutting robots. These, for example, will later be the windows of a crew member's cabin in the deck house. Then the cut steel pieces are prepared for welding. Before they become a ship, the 140,000 steel pieces have to be welded together with a total of about 700,000 meters of welding seams. Our welding robots do this job fully automatically. This block already contains about 150 tons of steel and is now ready to be moved to the building dock. Now it is time for one of our most important pieces of construction equipment to become involved, our giant gantry crane. Its size alone makes it very impressive. 148 meters wide and about 80 meters high. This crane has been a landmark on Foon for 30 years. This crane assists in the positioning and assembling of the more than 130 blocks in the building dock, each block weighing hundreds of tons. The dock is 415 meters long and 90 meters wide. This unique production technique is one of the reasons for the shipyard's success, and the crane is of crucial importance to the production plans. The 3rd of December 1999, one of the most severe storms of the century hits Europe. In Denmark, the storm exceeds gale force, resulting in massive destruction. And then something happens at the Odense steel shipyard that has never been considered possible. The large gantry crane, weighing more than 3,500 tons and positioned over the construction dock, is hit by a strong gale. The crane sways and crashes onto a ship that is under construction below. After a moment's shock, it becomes apparent that this is a complete and devastating loss. Now the first step is the removal of the wreck of our huge gantry crane, which means moving 3,500 tons of steel. This task has been undertaken by the Dutch company Maersk. A week later, they bring in and erect a huge special crane and other equipment and immediately start removing the wreck. The team is working day and night. At the same time, we had to find a way to continue building ships despite the loss of this very important gantry crane. Maersk also presented the solution in the shape of 5 spectacular mobile crawler cranes with experienced operators that enabled us to continue building ships according to the revised production schedule. Seeing how these 2 crane operators handle this complete bow block is like watching circus artists. In the meantime, negotiations were carried out regarding the specifications and construction of a new gantry crane. This new crane will be designed even bigger and even more advanced to meet the requirements for the yard's future building plans. The chairman of the A.P. Møller Group, Mr. Maersk Møller, impressively demonstrated his innovative entrepreneurial thinking in his speech when the new crane was inaugurated.
It looked like a calamity for the shipyard and for its clients. But necessity is the mother of invention.
The contract for the new gantry crane was awarded to Maersk in Germany, who guaranteed the new crane would be ready to operate within 18 months. Maersk immediately started designing and constructing the new gantry crane, and just a few months later, the first parts of the new crane were delivered to Lindau. Some came by trucks, some came by ship from Gdansk in Poland, where the large cross girder was manufactured in 3 parts, each weighing about 1,000 tons. These parts were unloaded at the yard and transported to the crane assembly area.